Observe very carefully. If the ball is moving forward direction, for example, the ball is hidden by Mr. Arun Kailash. Now the ball is rolling on the ground. Ball is rolling on the ground. Now in these two examples, we can make negative work done. So now tell me, one in what is the cases? For example, first, if you want to stop the ball, two ways we can. One is a fielder who is present here. He will apply the force in which direction? Everybody check it, everybody. He will apply the force in which direction? He wants to stop the ball. He will apply the force in this direction. But motion in which direction? Motion will be in this direction. So in this case, what is the work done? Work done by the what? Negative work done. Do you understanding? Now, in another case also, if you are not stopping the ball also, ball will come to rest due to some other force. Anybody can tell?
Friction.
Frictional force. That is what the answer I'm expecting from you all. If this is the ball, if the ball is rolling like this, motion of the ball will be like this direction. Now, some other force trying to stop the ball is acting. What is the angle? Check it. How much angle it is? Frictional force, exactly opposite. How much angle, Harish?
180.
180 degrees. Understand, Akilan? Negative work done. Understanding work done by the frictional force is negative. Please write it. Work done by the frictional force is negative. Are you clear? Everybody? Anything doubt? Please let me know. Arun, Danishkar, Harish Jairaj, Aswin?
Yes, sir.
Yes. That is very, very important. In which case work is positive, in which case work is negative. Now, for example, all of you observe, suppose if this is the inclined surface, now I have given a task to lift the load in this direction. Now check it, all of you. Suppose a person is standing behind and he applied the force in this direction. Now tell me, displacement will be in forward or backward direction?
Backwards.
Yes, all of you?
Displacement will be forward, sir.
Displacement will be in forward. It is inclined surface. It is inclined surface. Now tell me.
It is in backwards.
Yes, that is what. So he
Yes,
applied the force in forward direction, but he release it. What will happen? Displacement will be in what direction?
Backward direction.
Backward direction. So the displacement will, ball will roll towards the back. So we are trying to push forward, but the body is displacing backward when an inclined surface. Do you understand, everybody? So that is why in this case also we can say work is negative or positive.
Negative, sir.
That is you have to remember. Okay, but anyhow, 3 examples is enough. You can learn these 3 examples. Any doubt, anyone can ask. 3 examples for negative work done. Clear, guys? Omar, Gokul.
Yes, sir.
Next, last one. What is the third type of work done, everybody? What is the third type of one? Zero work.
Zero.
Okay, so you all knows what is zero work done. Everybody? What is zero work done? That angle is equals to how much? Angle between the force and displacement.
0, sir.
90 degrees, sir.
Now 90, sir. 90.
That is okay, right. When the angle between the force and displacement force and displacement, am I teaching fast, Harish? Is it okay? Can I teach more slowly? Force and displacement is 90 degrees. 90 degrees. Then what is the work done, Danishkar? Work done by the force is equals to how much, guys? 0. So in this case, what is the theta? If theta is equals to how much, guys? 90 degrees.
90 degrees.
Then cos theta is equals to cos 90. So cos 90 is equals to how much? See the table and tell me.
0, sir.
0. That is 0 number. So in this case, work done is equals to Fs cos 90 degrees. So equals to, as we know, Fs cos 90 is 0. So everything work done is equals to what?
0, sir.
0. That is what it is. Next, in another case also work done will be 0. Can you tell me what is the case? Not only angle is 0, angle is 90. Some other case also force will be 0. Any other? Anybody's? First day itself I told you that. If suppose force is 0, displacement is 0, then work done is 0 or not? Not only the angle. Yes or no?
Yes, sir.
So work done will be 0 in 3 cases. Work done is 0 in 3 cases. What are the 3 cases? Anybody tell me? First case, angle is equals to how much? 90 degrees. Second case, F is equals to 0. Third case, displacement is 0. If any one is existed, then totally work done is equals to 0 or not? Everybody, I want the answer.
Yes, sir.
Yes?
Yes, sir.
What you want
Yes,
to
sir.
remember. So if cos 90 also 0, or force is 0, 0, displacement is 0, 0. So put the statement. If either force or displacement is 0, if either force or displacement is 0, displacement is 0, or both are 0, both are 0, then also work done is what? All of you.
0, sir.
That is you have to remember. Clear? Clear? Understand, guys? Now, can we go for the examples? Everybody? All of you?
Yes, sir.
Examples. So examples, this is not a new to you people. So already I have taught you. So how many of you know tangent to a circle? Tangent. So you can take any kind of things like a planet centripetal force. Do you remember that gravitation chapter centripetal force we studied? Yes or no? So let us take that again. Now first example, centripetal force only. You all can take. Now you can notice it. For example, at every point, direction will be perpendicularly to the applied force. Is it right or wrong? So let me take now. That is the center of the circle. So this is the center of the circle and applied force will be like this. What is this force called as? From the center acting force. We can call some name. Anyone?
Centripetal
Centripetal force.
Centripetal
Centripetal
force.
force.
Centripetal force acting towards to the center or away from the center? Always. It will act.
Away from the
Center.
Hey,
Sir, yes, sir, towards the center, sir.
check it. Centripetal force acting towards the center or away from the center?
Towards the center, sir.
Towards center, sir.
Towards the center. Understanding centripetal force. That is. Now, direction of motion at every point. If I check this point, check this point or any point, it will be always tangent. So if I'll write tangent, what do you mean by tangent, guys? Gravitation chapter. A line which is passing through how many points? How many points? 1 point from the surface of the circle. Understanding? So that is what we used to call as tangent. It is there in gravitation chapter. Verified orange color table. You know more. Is it right or wrong? Tell me the page number, Harish, so that everybody will see. Gravitation chapter. Direction of motion. So what is the angle between them? Verify it and tell me how much angle here? At every point, what is the angle?
90
90 degrees. So work done by centripetal force. Is it zero work done or positive work done or negative work done? Everybody. Work done by the centripetal force. Is a positive work done or negative work done or zero work done? All of you. Yes, please.
0 done, sir.
Zero work done because cos 90 is equals to 0. So that work done is equals to Fs into 0, which is equals to 0 joules. Please write it. First example, work done by the centripetal force.
Sir, page number is 132, sir. NCRT book, sir.
Page number 132, NCRT book, all of you verify it. Tangent. If you draw a tangent to a circle at any point, all of you remember, centripetal force means you can see if this is the center, I can draw a tangent here, I can draw a tangent here, I can draw a tangent here, I can draw a tangent here. At everywhere, what is the angle between that? All of you. You have to respond. What is the angle? Everywhere it will be how much?
90 degrees, sir.
90 degrees only. Understanding? So everywhere is a 90. So that is why the work done by the centripetal force is equals to how much? 0 degrees. Sorry, 0. That is what you have to remember. Clear? Page number 138. Everybody verify it. Is there or not? Harijeras. Page number 138 NCRT. Drawing a tangent. Tangent means a line passing through the surface of the center by touching only one point. That is what you have to remember. Mr. Nimish, have you found it? Next, second case, second example, right? Work done by a coolie. Second example. Draw the diagram also. Work done by a coolie. So if you take a coolie, railway coolie or whomever the coolie, so he will carry the load on whom? Where he will carry the load? You have to tell me. Where he will carry the load? All of you? Nobody will answer. Where he will carry the load, guys? He will carry the load on where? On his head. Correct or not? So let us draw now. You will understand. So that is the direction of force. He will apply the force in what direction? Mitakshri? Upward or forward direction? Upward direction or forward direction? I want the answer. Downward or upward direction? Coolie. He wants to carry the load. Upward direction or downward direction? All of you? No response. He is putting the load on your head so that you will apply the force in upward direction and downward direction to carry the load.
Upward.
Now, for
Upward
example, let me take. This is you consider, all of you. So, the force is applied in the upward direction. Why? If you consider this is the, suppose for example, a railway pulley, he will carry the load on his head. This is the load. Now he is carrying the load means applying direction force he with his hands. He is applying towards the upward direction and downward direction. Check it, everyone. Respond. Okay, Harish, page number 132, Amma, not 138, 132 it is. So tell me, he is applying what direction, guys? I want the answer. Upward direction or forward, upward or downward direction? Nobody will answer. Upward or downward direction, right?
Upward direction.
Upward direction. This is the load or luggage. Understanding? Now, direction of force is upward. Now, direction of motion will be forward direction. Understanding? You consider this case also, or you imagine a boy is like this motion. Actually, it is a three-dimensional one, so that I am representing. Now tell me what is the angle between them? How much is the angle? Direction of motion. I am representing here. How much is the angle?
90 degrees, sir.
90 degrees. So that what is the work done in this case?
0, sir.
That is because he is moving horizontally. He is moving horizontal plane. Understanding all of you? He is moving on horizontal platform and applied force is upward direction. So that direction of motion is like this, applied force is like this. So tell me what is that? Displacement is like this. So what is the answer? What is the angle? Work done by the coolie. Work done by the coolie is equals to F into S into cos 90 degrees. So which is equals to how much? Total work done by the coolie, which is equals to work done. Why? Even though here force is applied and displacement is there, but who is not there? Angle is 0. Angle is 90. So that it is what? 0 work done. So even though he carry the load 1 kilometer, after that his work done by the coolies, he may become tired. He may be lost the energy. He has been walked more than 1.5 kilometer, but still the work done is 0 because the force is applied what direction? Perpendicularly to the whom? direction of motion. Understand everybody? Clear or not? Respond.
Yes, sir.
That is. Okay, next, third case. Now let us imagine, for example, this is a third example. Third example, check it everybody. Zero work is done when we push a wall. Zero work is done when we push a wall. So in this case, so for example, observe very carefully. This is the wall. In this case, the applied force in all is not the, sorry, applied angle and all is not the zero, but something is zero. Everybody, this is the wall. Now let me imagine Mr. Harizera is applying the force. He is doing the exercise and he is trying to apply the force in this direction. It is not, of course, it is not perpendicularly also, with some obliquely also. Now in this case, force is there and theta is also not 90. Then tell me, see that even theta is not 90. If he is applying exactly like this, okay, we can consider theta is equals to 90 degrees. This is the wall and this is the applied force, but he is applying the force in this way, some direction. Okay. So now tell me, in this case also work done is zero. Why?
Sir, displacement is 0. Sir.
Displacement is 0.
That is the thing. Okay. So in this case, you have to write a boy is pushing a wall. You can write the explanation. Zero work is done when we push a wall. Right. A boy is pushing a wall for so long, by applying large force on it. But wall does not move. But wall does not move. But wall does not move. Means displacement in the wall is zero. Means displacement in the wall is zero. So if S is zero, what do you mean by everything will become what? S is zero. Hence, work done is equals to what? All of you.
0, sir.
That is, work done is zero. That is what? So we will write W is equals to Fs cos theta, which is equals to 0 joules. You have to remember. Clear? Now, all of you, negative work done, positive work done, and zero work done. Yes, Mr. Hariseras? Yes, please, Danishkar, Gokul, Noor. Anything doubt, Mr. Asmin? That is what you have to remember it. So, if you have been understand this, then we will solve most of the questions related to the work done. So whatever the question will come, we can able to solve. This is what is the first part of the chapter. As we know, 3 parts will make the chapter. First one is work. Work is entirely related to this only. Positive work done, negative work done, and zero work done. So in the exam, they will ask you which is what. You must find it. Positive work done or negative work done or zero work done. And they will ask you some numericals also related to that. That's all. So other than this, nothing they will ask you. Is it okay, guys? Clear? So till here, with this I will stop the today's class. Then in tomorrow's class, we will proceed with some examples we'll solve. And later that, we will go to the next part. That is what we used to call as energy. Is it okay? So thank you. With this, I will stop. We'll continue continue from here in tomorrow's class. Thank you all.